Hello my dear students, how are you? I hope all of you are doing very well enough. Okay, if you remember in the last class, in the last video we discussed about scalar dot product of two vectors. So today in this video we will be discussing very briefly again the vector cross product of two vectors, some of their properties, and how to find out the area of a parallelogram using vector cross product, area of a triangle, area of quadrilaterals. And then of course we are also going to be studying how to find out the vector cross product of two vectors when their angle between them is not given using the determinant method, which is a very interesting method to find out the vector cross product. And we'll be doing some examples on that also, one or two examples on how to find out the vector cross product using the determinant method, which is basically more useful in calculating mathematics problems. So all that we'll be doing in this video. We'll try to keep it very brief as possible, but certainly topics we cannot be so brief, so we'll be discussing according to these certain topics. Now, if you remember in the last video, we discussed about multiplication of a vector by scalar and also scalar dot product. So if you remember if we had two vectors, vector A and vector B, then the scalar dot product of two vectors would result in A dot B equal to magnitude of A into magnitude of B into cos theta. So those who haven't written down the notes, of course you can always pause the video and then write down the notes also. Okay, if you want to pause, yeah, you can pause it there and you can write down. Okay, alright. Today we will be learning vector cross product of two vectors. Cross product, okay. So vector cross product of two vectors will result in almost the same value, that is not value, same value, but almost similar, okay. That is magnitude of A into magnitude of B into the only difference is going to be sine theta. One of the only differences, sine theta n cap. Now what is this n cap? We'll be discussing that in detail also, but this is how the formula is going to be different from each other, because as the name suggests, and in that previous video also we discussed briefly that scalar dot product of two vectors will result in a scalar quantity. That's why it was scalar dot product. This is vector cross product. That means the cross product of two vectors will result in a vector quantity. As I mentioned here, the product of two vectors, when it's vector dot vector, will result in a scalar. Vector cross vector will result in a vector quantity. Okay. Now what is this n cap? I'll help you with that also with the help of some diagrams and all, but as the definition goes, that is where n cap is a unit vector which will be perpendicular to both vector A as well as vector B, perpendicular to the plane of vector A and vector B, such that vector A, B, n cap form a right-handed system. Now what is this right-handed system? We will discuss about that, but I think you've written it down. So this is going to be the formula for cross product of two vectors. Now the main importance here will be this n cap. Okay, what is this n cap? Because this is the quantity which will give us that vector quantity, because all these are magnitudes only. So this quantity is a scalar quantity only, just like the vector scalar dot product. Okay, this will help us in giving us that vector quantity, and since the result is a vector quantity, that resultant vector will also have a direction of its own, isn't it? So that direction is very, very, very useful in basically not in mathematics but in physics. Okay, so even the physics students can gain a lot from this video. Okay, now see, vector cross product of two vectors. Now that is equal to this magnitude of A, B, sine theta into n cap, where n cap is a unit vector which is going to be perpendicular to both vector A and vector B. That is, if we have two vectors, vector A, let's say this is our vector A and this is our vector B, and they are making an angle theta. So their cross product as it is given here. This n cap, what will be the direction of our resultant vector now? Now for that, of course, there are many rules given by many ways to find out the direction of this n cap. But of course, it does tell us that this n cap is going to be perpendicular to the plane of vector A and vector B also. That means that resultant vector will be such a vector that is going to be perpendicular to vector A as well as vector B. Very important property. Always keep that in mind. Now, we have this right-handed system, we have this right-hand palm rule, we have this right-hand screw rule also, all these systems. Now, I'll try to teach you two methods, which will be very helpful in physics also. I'll try to teach you two methods in finding out the direction. Basically, now in mathematics, we are generally not very much focused on the direction of the resultant vector. We'll be more focused on the mathematical part only, but still then, it's always important, isn't it? It's always important. Now, the right hand palm rule, which is very simple, okay, right hand palm rule, the right hand palm rule system, or the right hand system, that is like, if you are going for the cross product of two vectors, let me just rub it off, okay, let me just rub it off, let me give you the two diagrams on how to find out the direction of two vectors. So we have two vectors, let's say vector A and vector B, and this is the angle that is, but we are not going to be interested in the angle as of now. So if I'm trying to go for A cross B, then what is going to be the direction of the resultant vector? That is an n cap unit vector perpendicular to both A and B. Now, for that, you can take your right hand, okay, you can take your right hand, alright, you can take your right hand, alright, okay, right hand, and then I'm going from A cross B, that is from A to B, isn't it? A cross B. Now in that system, if you place your right hand towards A, okay, right, your palm, your fingers pointing towards A, only the right hand, okay, no left hand. Your right hand towards A, okay, in the direction of vector A, and then like try to curl along the direction of the cross product, that is A cross B. Okay, A cross B. Alright, cross B, A cross B. You can roll your fingers towards that. That is A cross B. Now in that, what happens is you have to keep your thumb loose. A cross B. In that, when we do that, what happens is your thumb, the direction in which your thumb points, that will be the direction of the unit vector, the resultant vector. Alright, so in this scenario, what happens is when I try to curl, by placing from A cross B, my thumb is pointing towards U. That is, it's pointing outwards of the plane of the board. Alright, got that? So that's going to be the direction. Alright, another system, that is not another system, the same system if we go for something like this. That is, if this is my vector A, this is my vector B, and then this time again, it's like A cross B. And in that case, it's going to be A cross B. So in that case, what will happen is I will be pointing my fingers towards A only, right, and then try to curl my fingers, that is A cross B, A cross B. In that case, what happens is my thumb, of course, is pointing inside. My thumb is pointing inside. That's the only way, because this way I cannot do, isn't it? Right, because I have to curl my fingers towards B, A cross B. So in that case, what happens? My thumb is pointing inside. That means the unit vector will be in a direction pointing inwards of the board. But in this case also, you can see, in this case also, what happens is this thumb is going to be perpendicular in this direction. Like in this direction. So the unit vector definitely is perpendicular to both vector A as well as vector B. Plane of vector B. Perpendicular to the plane of vector A and vector B. Similarly, when it's going inwards, perpendicular to the plane of vector A and vector B. That's how we get the direction of the resultant vector. There's another system which is also known as the right hand screw system. Okay, right hand screw system. Almost the same system, but this works. Okay, as I said, curl your fingers towards the direction of the cross product. The thumb, right hand, the thumb will point the direction, give you the direction of the resultant vector. Another system is the right hand screw rule, that is A cross B, that is same. If I have to go for the direction of, like, if I have to find out A cross B, then in that system, imagine a screw, okay, imagine a screw. Alright, imagine a screw, and then if you are going from the direction of A cross B, then you'll have to imagine this, okay, imagination holds the key. So when you go from A cross B, that means you're trying to screw that particular screw or that nut towards from A B, that is towards this direction, that is anti-clockwise, isn't it? Anti-clockwise. So in that case, what is going to happen? Generally, those who are, maybe you can try that later on also, like those who are interested in carpentry and all these things and all, they will basically know about this. So when we try to roll a screw in the anti-clockwise direction, what happens? The screw will come out, isn't it? The screw is going to come out, that is, it's going to be pointing outwards. And if you want to go for, like, let's say B cross A, then in that case in this direction, so in that case we are rolling towards in clockwise direction. So when you roll a screw in a clockwise direction, what happens? The screw points inwards, but always remember perpendicular to the plane of vector A as well as to the plane of vector B, perpendicular. All right, so that's how we get the direction of the unit vector. And and finally we can say that the vector cross product of two vectors will always result in a vector quantity. All right, so I think that's clear. Now with that, of course, some special conditions, like, okay, let me just quickly write down, that is A cross B is magnitude of A, magnitude of B, sine theta n cap. Some special conditions, that is, if the angle between the two vectors, if theta is the angle between the two vectors, if the angle between the two vectors, vector A and vector B, is 0 degree parallel or 180 degree pi, then in that case what will happen? A cross B, let's not waste time here, A cross B will be magnitude of A, magnitude of B, sine 0. Sine 0 is how much? 0. Or sine 180. Sine 180 is also what? 0. So in that case, A cross B will be 0. Slightly different from the dot product. So if two vectors are parallel to each other, A cross B is going to be 0. If you remember in dot product, if it was perpendicular, then the dot product was 0, isn't it? For cross product, if it's parallel, then the cross product is going to be 0. So with that said, if you go for two like vectors, cross product of two like vectors, A cross A, that means they are in the same direction or parallel, yeah, in the same direction and parallel. In that case, what happens is, A cross A, the cross product of two like vectors will always result in 0. Alright, is that clear? Alright, another case will be like, if vector A is a 0 vector or vector B is a 0 vector, then in that case also A cross B will definitely result in a 0 vector. Remember in scalar dot product, this was just 0. Alright, but this, since A cross B cross product will result in a vector, this will be 0 vector. Alright, 0 vector. Okay. Alright, so that is what cross product is all about, and we will be emphasizing in mathematics mostly on the mathematical part. So the direction part I already have shared with you also, so even that direction part will be helpful when you do physics, alright, especially in magnetism and all those topics. How to find out the angle between two vectors? How to find out the angle between two vectors. How to find out the angle between two vectors? So if these are two vectors and if this is the angle between the two vectors, then remember how we calculated that for dot product. If you just write down the formula, that is A cross B will be equal to what? A B sine theta n cap. What is n cap? A unit vector perpendicular to both vector A and vector B. Now to find out the angle between two vectors using cross product, what we do is we try to take the magnitude on both the sides, that is modulus on both the sides, that is magnitude. Now what is magnitude of A? It will be same, that is again magnitude of A. Magnitude of B, magnitude of B. Sine theta will always be a sine theta only, isn't it? We're talking in terms of magnitude only, alright? Magnitude. So what is magnitude of 4? Modulus of 4 is again 4 only, isn't it? Doesn't change. And what is the magnitude of n cap? As I said, n cap is a unit vector, so its magnitude also is going to be 1. So if we just cross multiply, then sine theta will be magnitude of A cross B upon magnitude of A into magnitude of B. So using cross product, the angle between the two vectors will be, if I just again, I don't want to write on the other step, it's going to be theta equal to sine inverse of magnitude of the cross product A cross B upon magnitude of A upon magnitude of into magnitude of B. Alright? Okay, you can note it down. Alright. Now, let's talk of, okay, another formula, that is, sometimes the question will be like, find out that n cap. find out that n cap. Okay, find out that n cap. What is n cap? It's that resultant vector, unit vector, which is going to be perpendicular to both vector A and vector B when you go for the cross product of two vectors. Sometimes the question is find a unit vector which is perpendicular to both vector A and vector B. Alright, for that I'll just give you the formula, that is a unit vector, a unit vector perpendicular, I'll just write it in short, perpendicular to vector A and vector B. I'll just give you the formula, that is n cap. Alright, n cap will be equal to A cross B divided by magnitude of A cross B. So this will be the formula that you will be using if you are told to find out a unit vector perpendicular to two given vectors, and that will be given by n cap equal to A cross B divided by magnitude of A cross B. Okay, alright. Next, let's talk about some properties again. Alright, let's talk about some properties of cross product. Properties of cross product. First one, if you remember in dot product, we had seen that dot product of two vectors is commutative. Is it going to be commutative in cross product also? No, because A cross B is not going to be equal to B cross A. That we have already seen in that diagram also. When we go for the direction of A cross B, it will be pointing outwards, but when you go for B cross A, then in that case it's going to be pointing inwards. That means the direction is going to be different. So commutative property does not hold in vector cross products. So A cross B will not be equal to B cross A, rather it will be negative. That is, the direction will be reversing inwards, outwards. Alright. Second property will be, then just note down, I will not be discussing in details about all these properties, just especially important for maybe in multiple choice questions and all. Alright, so minus B cross A will be equal to A cross B based on the direction, that is minus B cross A will be equal to A cross B minus plus, right, will also be equal to B cross of minus A. This is all based on the focus of direction. Number 3 will be when you multiply the cross product of two vectors by a scalar quantity, where m is that scalar quantity. That will be same as m of vector A cross B or A cross m of vector B. That scalar quantity will not have much difference on that. And then the distributive law holds for both positive addition and subtraction for cross product. That is A cross B cross vector C will be same as A cross, it holds, the distributive property holds, that is A cross C. That is A cross of D plus C will be A cross B plus A cross C. Alright, similarly, it holds for negative also, difference also, that is B minus C will be equal to A cross B minus A cross C. Alright, that is, okay, A cross B minus C will be equal to A cross B minus A cross C. Alright, and the other property which we already discussed in the beginning of that video, that is another property, that is number 6, that will be A cross B. If A cross B results in a zero vector, then it implies that either vector A is equal to 0, okay, or vector B is equal to 0. Alright, or what are the other conditions? Either vector A equal to 0 or vector B equal to 0, or the two vectors are parallel, that is vector A parallel to vector B, or the final condition, that is vector A and vector B are collinear or parallel also. Okay, so these are some of the brief properties of vector cross product, briefly given to you. Okay, now let's discuss about how to find out the area of a parallelogram. So I'm going to be just giving you the formulas only, how to derive them and all that we will not be doing here. That is number 1, that is area of a parallelogram. How to find out the area of a parallelogram using cross product. Now if vector A and vector B. If vector A and vector B denote the two adjacent sides, okay, immediate sides of a parallelogram, then the area of a parallelogram will be given by magnitude area. Area will always be a scalar quantity. So magnitude of A cross B. Alright. Similarly, what will be the area of a triangle? Area of a triangle. Now, if area of a parallelogram from the class 9 geometry portion, area of a parallelogram. So, if you have a parallelogram in terms of area, a parallelogram can be kept into two equal halves, each representing a triangle. That is just half of the area of the parallelogram. Just using some simple concepts. Alright. Of course, as per the theory that states is if A and B denote the two adjacent sides of a triangle, then the area of the triangle is given by half of A cross B. But we can just use that same concept also. Third one will be how to find out the area of a quadrilateral. Of course, parallelogram is also a quadrilateral, but parallelogram does not describe the entire properties of quadrilateral. What is a quadrilateral? It's just any four-sided figure, isn't it? So, if we have a quadrilateral, any kind of a quadrilateral, okay, A, B, C, D, where AC and BD represent the diagonals of a quadrilateral. Then using the diagonals, we can find out the area of any quadrilateral, provided of course we have the diagonals, okay, and that area of a quadrilateral will be given by half of the magnitude of the cross product of the diagonals. Half of the magnitude of the cross product of the diagonals, AC cross BD. Alright, half of AC cross BD, where AC and BD are their respective diagonals. Fine? Okay. Now, one of the most important parts that we will be learning now, that is the autonormal triad vector product of an orthonormal vector triad. That is vector product of an orthonormal triad. If you remember this system, that is, I'll just keep it under anti-clockwise direction, I, J, K. I'll just follow this anti-clockwise direction, I, J, K. So if you remember, while we were doing dot product, I dot I. What was I dot I? I dot I was 1, isn't it? We had discussed about that. Now let's see what happens with the cross product also. Alright. What will be I cross I? I cross I. I cross I will be what? Let me just derive that one. I sine 0 degree upon the unit vector. Let's keep that unit vector as it is. That's 1, 1. What is sine 0? 0. So this will not play a part as of now. So similarly, cross product, already we discussed about that A cross A is going to be, cross product of two line vectors are always going to be 0. J cross J, K cross K will be of course what? 0. Alright. Okay, so that's how it's going to change. Okay, that's how things are going to be slightly different now. That means I cross I, J cross J, K cross K is going to be 0, unlike in dot product, which was 1. Okay, then what will be now basing on this direction I, J, K? What will be I cross J? Let's derive that. I cross J. That's going to be magnitude of I, magnitude of J, sine of theta. What is theta that we will discuss? Sine of theta will be what? 90 degrees, isn't it? Because if this is the unit vector I, if this is, let's say, J, and if this is K. Remember this K vector is actually, of course, I have no other option since this is a two-dimensional space. This K, of course, I have to draw, but remember this K is like pointing in this direction. Alright, in this direction, perpendicular to I as well as J, alright, in this direction. Got that? Now n cap, what does n cap represent? N cap actually represents that unit vector which is going to be perpendicular to both vector A and vector B. Now what is the unit vector which is perpendicular to both I and J? It's going to be what? K vector, isn't it? So that result is going to be K cap. So this is 1, this is 1. What is this? This is also 1. That means I cross j will give me k. Alright, I cross j will give me k cap. Alright, where k cap represents the unit vector which is perpendicular to both I as well as j. Similarly, if we follow this autonormal triad, if you follow this system, that is this cyclic system, that is I, j, k. Now let's play this cyclic system a little bit. So I, j equal to k. So let's follow this. I, j, next j, k. That is j cross k. So I, j gives us k. So what will be j, k? J cross k will give us I. Let's not derive that. Alright. So I, j done, j, k done. So what is next? K, I. So k cross I will give me, k, I will give me what? J cap. Okay, so these are important things which we have to remember. But, okay, got it? Now, but if I just change the direction, that is like I, j was k. If I go for now reverse, j cross I. No, I, j was giving me k. Isn't it? Wasn't it? I cross j was giving me k. So if I just reverse this, j cross I, of course will give me k, but the direction has changed. So that's going to be what? Minus of k. Similarly, k cross j will give me minus I cross k will give me minus j. Okay, so these are some important things which is needed for us. Okay, alright. Next. Finally, let's learn how to find out the vector cross product of two vectors. Vector cross product of two vectors. Imagine, let's say x represents another one vector, that is ai plus bj plus, of course we will do an example on this also. Okay, y vector represents abc, di plus abc, de, f. Let's just use these letters instead of using a1, a2 and this and that. Now, if the question is find out the cross product of x cross y, of course as per the formula that's going to be x magnitude of y sine theta n cap. Now the problem here with us is, where is theta? Now if theta is not given, then what shall we do? Of course there are ways to derive that, definitely, but it's going to be a bit lengthy, of course. Alright, okay, but if we can do it in another way without actually finding out the value of theta, if the question doesn't demand so, without finding out the actual value of theta, then we will do it the other way around, isn't it? Why waste time find out the value of theta? Okay, so there's another way to solve this. Okay, that is without using theta. If theta is given, of course definitely we can just use this, no problem with that. Alright, it's going to give us that vector. But if theta is not given, then in that case what shall we do? So in that case, of course, we have one very beautiful method which is called actually the determinant method. You remember matrices? D-E-T-E-R-M-I-N-A-N-D, the determinant method. So if you remember, do you remember matrices? In matrices and determinants, if you remember, how do we find out the value of the determinant and all that? Same concept we will be using. Okay, same concept. So that's going to be easy for us to remember also, because we have already done determinants. So that's going to be always easier for us to remember. But how do we do? Let's see. What you will do is you will prepare your determinant. Okay, what you will do is you are going to be preparing your determinant, and then write down the unit vectors I, j and k of the respective axis I, j and k. And after that, what you will do is, if it's x cross y, serially you will write down the coefficients of vector x first, that is a, b, c, vector components, coefficients of the vector components, a, b, c. Then y, that is d, e, f. Prepared. Once it is prepared, all you will do is try to remember how we used to find out determinant. Expand along row 1. Okay, expand along row 1. That is, how do we expand along row 1? That is I cap. So we neglect this row, this column and this row. So that will be b into f minus c into e. Wasn't it? Minus j. Now expand along this by ignoring this row and column. That is a into f minus C, A, B, C, this was D. C into D, right? Plus the finally K. So ignore this and this. So that's going to be A into E minus B into D. So the same concept of determinants we'll be using to find out the vector cross product of two vectors without using the value of theta. Now in some textbooks, one note that we have here is, of course we'll do one example also. In some textbooks this will be given plus. Okay, this will be given plus. It's okay, don't worry, trust me, don't be confused with that. Let's not try to learn so many different formulas. Okay, let's just use the concept of determinants. All right, of course, but you may be wondering like why is it written plus, why aren't you telling us? Okay, I'll tell you. If it is written plus, then what happens is this is actually reversed. Okay, they reverse this, that is CD minus AF. So it's all the same. That is why for us, maybe if we just want to prove it, then we can just take minus common. Then in that case, again back to our old formula, that is AF minus CD. Alright, so don't be confused with that. No problem, you just follow the determinant method. No need to go for a mixture of so many different formulas. Okay, so that will do wonders for you. Alright, so now with that, let's try to do one problem. Let's try to solve one problem. Let's try to find out the cross product of two vectors. That is, let's say one vector, another vector. Let's say vector A is, let's say 3i plus j minus 4k. Alright, and the other vector, let's say 6i plus 5j minus 2k. Alright, let's begin. Let's go for A cross B. What do? Prepare our determinant, write down the unit vectors I, j, k, and then write down the coefficients respectively. A first, that is 3, 1, minus 4. Then for B, 6, 5, minus 2. And then expand along row 1, that is, let's prepare like this, I minus j. Always be systematic when you do mathematics. Okay, very, very important in mathematics. So prepare this, then go for the cross product, that is first one, ignore this. So 1, 2, minus 2, minus 4, 5 are minus 20. So okay, we can just write minus 20. Alright, next for j, ignore this. 3 2s are minus 6, minus 6 4s are 24, minus 24, minus 24. Careful with the negative values. Okay, careful with the negative values. Simple multiplications can cost you marks. Careless mistakes. Similarly, k, ignore this. 3 5s are 15, minus 6 1s are 6. Now let's solve this. Minus 2 plus 20i minus 6 plus 24j plus 15 minus 6, I think that will be 9. Alright, so ultimately our value 18i minus, how much is going to be this? 16, that's going to be I think 18, isn't it? 18j plus 9k. So alright, I think that's alright. So 18, 19, 20, 21, 22, 23, 24. Yes. So there we have it. So what do we get here? We go for the cross product of two vectors. Like, alright, we go for the cross product of two vectors, use the determinant method, and then ultimately, finally, what is the result? The result is also a vector quantity. Alright, so here the theta was not given to us, so without even using theta also, we can still calculate the cross product of two vectors. Alright, so that's all that we have for vector cross product of two vectors briefly. Alright, so next video, of course, we will be going for the exercises also. So I hope that this was useful. See you in the next video. Then of course, if you've liked the video, please do hit the like button also. Okay, alright then, see you in the next video with the exercises. All of you, take care. Bye bye.